So before I dive into what this video is going to be about, I just want to quickly go over the solutions for the last video, and these are right here on the screen. Just remember, it's just that thing we learned from the last video. When a is any real number, x to the a any real number, and we're integrating this, it's a plus 1 over 1, multiplying x, a plus 1 plus c. It's just the opposite of differentiation, because if you differentiate this, you'll get back to xa. So that's just that same rule. So pause the video to see these solutions. It should be pretty self-explanatory. If you have any questions, just drop them in the comments below and I'll help you. But besides that, let's get into the video. So this video is going to be about properties of indefinite integrals and the indefinite integral of x to the negative 1. So we have these three situations here. So let's look at this first one. We have k, and k here is a constant. That's an O. And one of the properties that we can observe with integration of this first one is that if you have a constant multiplying some function, so let's say this k is like 2, and this f of x here is just x, right? You can actually just factor out the 2 from the integral and do it as so. So what this looked like is you have k outside, f of x, dx. It's the same thing. This property is pretty important. It just sort of helps us do the more complex things a lot easier, and I'll be going through some examples in this video. But that's basically the first property. You can just factor out any constant. Second property is if we have two functions adding each other. So let's say if this was x squared plus x cubed, right? And we want to integrate this, right? What we can actually do, keep it in the green, we can actually just integrate the individual functions and add them up. So that would be f of x, so the integral of f of x plus the integral of g of x. In property 3, let's keep it consistent. It's the same idea. We can just take the integral of this and take the integral of this and then just subtract. So in 2 and 3 can be summarized by plus minus if you had to make a rule. Because both of these are just the same, it's just that there's a difference in signs. And then the first one is also pretty important, where you can just take out a constant to make the integration process easier for yourself. So that's the properties basically. So moving on to what would be the integral of x to the negative 1. So I think I can just show this to you straight. The integral of x to the negative 1 is actually just the natural log of that absolute value plus c. And you may be wondering, okay, how does that make sense? But let's think about it. If you recall the derivative of something like this, what would you get if you took natural log of that absolute value of x? If you took the derivative of that, what would you get? Well, you will actually just get 1 over x, right? Now, if you're differentiating this guy, this entire thing, so let's say, oops, no. We're taking the derivative of this, right? So this guy would turn out to be 1 over x, and c is a constant, so that's just 0, so plus 0, and 1 over x is just the same as x to the negative 1. So we see it works out. So that's basically it. I'm sure there's a proof out there to further illustrate this, but I'm just not going to bother showing the proof. But that is basically the integral of this. So let's do some practice based on what I've showed you. So we have this integral right here, and I think I will do this. Do this in this gold kind of color. All right. So one of the properties we learned, properties 2 and 3, is that we can actually split up this entire thing. So we can write this as 2x4 dx plus 1 over x dx minus 3x dx, like that. And then property 1 that I showed earlier is all about just taking out the constants. So we see there's a 2x4 here, so we can take out this 2. It leaves us with x4 dx plus 1 over x dx, because the constant here is just 1, so it doesn't matter. Minus, we have a constant 3 here, we can take that out, x dx, like so. And now we can just integrate. So we have, and keep in mind, since this 2 was multiplying this x, right, it's still going to be multiplying this thing here, right? These are still multiplying each other. So this would be 2 multiplied, integrating x to the 4, right? So recalling that first, rule we learned from the last video, 4 plus 1. Now, when we do indefinite integrals, we would obviously write plus c. But we have a bunch of integral terms here. So we actually don't need to write c. If you really want, you could write, c1. And then for this guy, you could write plus c2. And this guy, you could write c3. And then you can say c1 plus c2 plus c3 equals c. But you don't need to do that. That's sort of a waste of time. That's sort of like assumed, right? To show that, oh, the constant of this plus the constant of this and so on. Or actually, sorry. This would have, that would have, if we did this, it would have been c1 plus c2 minus c3, right? Gives us c because we have a subtraction sign there. But you don't need to do that. But so when we have a bunch of terms in, as so, what we can actually do is we can write the plus c at the very end once we've integrated everything. So we don't have to do that right now. 1 over x, this is just that other rule I just showed earlier. It's just the natural log of that absolute value of x. Minus 3 times 1 plus 1 over 1x 1 plus 1 plus c. We got the c at the end. So does that simplify to? Well, this is 2 times 4 plus 1 is 5, x5 plus this guy minus 1 plus 1, 2, 3 over 2, x2 plus c. So hopefully that makes sense and I wasn't too fast, but you don't have to write the c1, c2, c3. You don't have to show all those constants. You can just say at the very end when you have a bunch of terms. Let's try this guy. So what we want to do here actually, there's another way you can do it, but I haven't showed you any of the other cool ways, so we're just going to do it simply. Let's just expand this. This is some basic grade 10 math. So this is just x squared plus 3x plus 2. Right? Integrating this. And if you're confused as to how I got that, just times this, times this, times this, times this, add it all up. Now we're integrating such a thing. So first we can split it up. Always remember to write the dx, very important. And then I'm just gonna sort of skip some steps here instead of writing out more stuff. So I'm gonna just integrate this first term here. So this would give us 1/3 x third plus, because remember we're just applying that rule. So it's 2 plus 1, and then you have the 2 plus 1 here like that. This guy in this term, we have a 3 here. This is a constant, so we can factor out that 3, integrating this with respect to x, plus we have a 2 here, factor that out. This is just dx. And so let me sort of do a line like this so we don't get confused. So we have 1/3 x cubed. And would I write the c here? I'm actually forgetting myself. All right, you know what? Let's just not do it like that. I don't want to do the c1, c2, c3. So I'm actually not going to integrate this just yet, even though you know what it is. Okay, now I'm going to integrate everything. 1/3 x3 plus 3 times integrating this guy. 1 plus 1 is 2, 1x plus 1, 2 plus 2. This is basically an x0 here. So 0 plus 1 is just 1. And then plus c. We can add that c at the very end. simplifying this, 1/3 x cubed plus 3 over 2x squared plus 2x plus c. That is basically it for that one. Alright, moving on to this guy. So let's start off by making our life easier. Split it up. And then what we can do is we're just going to apply that rule again. I'm just going to write it out the side here. So we have 3 over 2 plus 1 over 1x, 3 over 2 plus 1, because 3 over 2 is a real number, plus 1/2 plus 1, 1x, 1/2 plus 1 plus c. So this 1 here, this plus 1, we can write that as 2 over 2. 2 over 2, right? And this 1 here, we can just write that as 2 over 2, 1x half plus 2 over 2 plus c. Hopefully I'm not going too fast, and hopefully you understand why I'm making it 2 over 2. I just want to illustrate that, you know, we can represent it like that so we can add it. So that becomes 1 over 5 over 2x 5 over 2 plus 3 over 2 1x 3 over 2 plus c. And then hopefully you remember some basic algebra, but when you have a fraction in the denominator of that can just go up. So that becomes 2/5 x5 over 2 plus 2 over 3, because this guy can just go up here, x3 over 2 plus c. And if you're ever unsure of if you've integrated something and if it works, just take the derivative of this. If you took the derivative of this, you know, you should end up at what was given in the question earlier, and you would. So 5 over, because we can, if we do the power rule, we swing this over. 2 over 5 times 5 over 2, this would cancel out. 5 over 2 minus 1, aka 5 over 2 minus 2 over 2 would give you 3 over 2, right? And you can do the same thing for this guy. So let me just undo that. So if you're ever unsure, just take the derivative, see if you end up with what you originally had. So that's basically it. I feel like I might have went too fast here. Sorry, it's just I've kind of a little bit of fun solving these. So here, I'll just leave it like this. Pause the video and see what I did. Hopefully that made sense. If you're unsure of this step, just think of it like fractions, like write it out like 1 divided by 5 over 2, right? You don't divide fractions, you do the reciprocal. It would be 1 times 2 over 5 kind of thing, if that makes sense. What I did here in this step is just this stuff. All right. Last question of the day. This horrendous thing here is dx. My handwriting is, you know, wonderful, as you know. So again, let's split this up based on the properties we learned. Once we do that, then let's factor out any constants we can. So we can take out this 22. And now let's just integrate everything. 22 times, because again, it's plus 1, 3 plus 1, right? We're just doing that. We're just adding 1. Oh, I want to undo. Nope, not that far. So plus 4, right? Plus, we have 1 over x minus 5 here, so this would give us the natural log of this absolute value of x, 5. Because this guy is to the, it's like the same thing as x to the negative 1, right? It's just now we have another term in there. Plus this 12 multiplying what we have here is an x0, so this just gives x plus c. Simplifying all of this, 22 over 4, we can divide both things by 2 to simplify. Divided by 2 gives us 11. 4 divided by 2 is 2, so you get 11 over 2x 4 plus this guy plus 12x plus c. And that is it. You are done. So hopefully this was helpful. In the next video, I'm going to go through some more practice, some more tougher problems. But besides that, drop any questions you have in the comments, and have a good day.